This video is on graphing quadratics in standard form. A reminder that quadratics in standard form is ax squared plus bx plus c equals y, or the function. We're going to do one example. In step 1, you need to find the vertex. To find the x value of the vertex, you use the formula x equals negative b over 2a. In this case, b is 6, so I'm going to go negative and then put 6 in for b over 2 times 1. And I'm going to solve that. When I solve that, I get negative 6 over 2 times 1, which is 2. And then negative 6 divided by 2 is negative 3. That gives me my x value of the vertex. So if I went off to the side, my x value is negative 3. We just need to find my y value. To find the y value, you go back to the original function and take out all the x's and put a negative 3. So instead of x, I'm going to have negative 3 squared plus 6 times my value of negative 3 plus 4. So then I'm going to look here and I'm going to go negative 3 times negative 3 is a positive 9. Negative 6 times negative 3 is a negative 18. And then a positive 4 at the end. So then I'm going to go 9 minus 18 is negative 9 plus 4 is a negative 5. So my y value is negative 5. So my vertex of this function is negative 3, negative 5. We're going to use that to find a couple more pieces in the problem before graphing. We're going to use a table of values in order to find the remaining points we need to be able to graph it. The vertex is going to go in the middle of the table. So my vertex is negative 3, negative 5. Once you have the vertex, you can pick 2 points above or below, or both, to find your quadratic. So I'm going to need to use negative 2, negative 1, as well as negative 4, and negative 5. We're going to substitute each of these numbers into the f of x equation to be able to find what y is. So my first one I'm going to substitute is negative 1. So I'm going to have negative 1 squared plus 6 times negative 1 plus 4. We're going to follow order of operations. So negative 1 squared is 1. 6 times negative 1 is negative 6. And positive 4. When we add those all together, we end up getting a negative 1. So the point is negative 1, negative 1. We're going to do the same thing with negative 2. Negative 2 squared plus 6 times negative 2 plus 4. So negative 2 times negative 2 is 4. 6 times negative 2 is negative 12 plus 4. Use order of operations. 4 minus 12 plus 4 is a negative 4. Okay, we're going to do the same thing with negative 4 by substituting it in. So we have negative 4 squared plus 6 times negative 4 plus 4. Negative 4 times negative 4 is 16. 6 times negative 4 is negative 24 plus 4 to give us 16 minus 24 plus 4 is a negative 4. That sounds pretty familiar. We're going to check that out here in a minute. And then lastly, let's do the negative 5. I have negative 5 squared plus 6 times negative 5 plus 4. Negative 5 times negative 5 is 25. 6 times negative 5 is negative 30, plus 4 gives us a negative 1. Again, negative 1 sounds familiar. So let's look here. Let's see what happened. This here is my vertex. And folding into the vertex, looking right here, and right here I have a negative 4. And if we go 2 away from the vertex, I have a negative 1 and a negative 1. That is because the vertex x value is also the line of symmetry. Once you have your table, you're going to graph it. Okay, we're going to go ahead and graph this starting with the vertex. Remember that the vertex was negative 3, negative 5. So I'm going to go left 3 and down 5, which is right here. And then I'm going to do 1 point away from the vertex. So let's do negative 2, negative 4, which is right there. And negative 4, which is right there. And then 2 away from the vertex is negative 1, and negative 5, negative 1. It's a good idea for it to cross the y, to cross both the x and y axis. So I'm going to go ahead and just evaluate one more point pretty quickly so that we can have a better idea of how this graph looks. So if I plug a 0 into my x squared, plus 6 times 0 plus 4, everything cancels but the plus 4. So I have another point at 0, 4. And because there's a line of symmetry here, and that this is 3 away, if I go 3 away here, I would have another point up there. And then we would draw our quadratic. Okay, so now the last step is to label. And there's a lot of different things to label here. So as we do them, we're going to check them off. The first one is the vertex. And the vertex is this point right here. So that's the vertex. And then the next one we're going to do is the line of symmetry. The line of symmetry is already in yellow, so I'm just going to put line of symmetry, LOS for short. Okay, the next one we want to do is the y-intercept, and the y-intercept is right here at 4. And then x-intercept, most likely there's going to be 2 x-intercepts if it does not come up with imaginary numbers or where the vertex is on the x-axis. So my x-intercepts are both here and here. There should be 2 of them. And then you can just label those x-intercepts. And then is there a max or a min? If the parabola is opening up, it's going to be a minimum at the vertex. If it is opening down, it's going to be a maximum at the vertex. So in this case, it's a minimum at the vertex because it's the smallest number that this will ever reach. In your notebooks, please tell me what vertex is, what line of symmetry is, what the y-intercepts are, what the x-intercept is, and what a minimum or maximum means. This way, when you look back at your vocabulary, you know what each thing means. Now I'd like you to try one. X squared minus 8x plus 3 equals y. Please find the vertex, graph it using a table, and label the vertex, the line of symmetry, the y-intercept, the x-intercept, and the minimum or maximum value.